Okay, welcome back everybody for the afternoon session of the EUROCAE Symposium. So I'd like to take this opportunity to thank our sponsors. So thanks to the sponsors for helping us with the setting up of this EUROCAE Symposium. So this is the first panel discussion of the afternoon. It's aviation security, global threats and mitigation strategies. So you can ask your questions on Slido. So the QR code is here. You can also get it in the program that you have. The questions, you can vote for the questions within Slido. So the panelists could look at the highest voted for questions first. So on to the panel. Effective mitigation of the current and future risks of cybersecurity or compromised systems needs robust risk management and the capability to respond to and recover from incidents when they occur. The panel of experts will discuss known threats and how current initiatives are addressing those threats. The panel is being moderated by Hans Elperson from the European Defence Agency. Hans has been working with the information and communication technology for over 20 years. At the European Defence Agency, Hans has implemented and manages the programme for aviation cybersecurity in military aviation. His activities include the representation of military interests in regulation and standardization. Hannes also acts as a trainer for EUROCAE, where he teaches aviation cybersecurity to civil and military aviation stakeholders. So thank you, Hannes, for leading this discussion, and the stage is yours.
Thank you very much. Thank you, Mark, for the kind introduction. A trivia question at the beginning. How do you know a pilot is in the room? Exactly. How do you know a cyber person is in the room? The amount of stickers on their laptops. No. Well, let me come a bit, I modified a bit my introduction to this panel based on the discussion we had in the beginning. And I think it was very important, and I would like to pick up from there. So we were talking about 1963. 1963, that was before most of us, if not all, here on the stage have been born. It was also long before even that we even thought about feeling incomplete when we forgot our smartphones at home, when we were out for dinner with friends, or when we didn't have enough charge for our smartwatches to monitor our sleep quality. But 1963 was also a time where aviation started to undergo a rapid technological development, and many of the technological developments from 1963 we're still using. Our aircraft and the ground system architectures have, of course, evolved, and we have managed to consistently improve aviation safety, or increase the level of safety, because safety is that what we care most about, isn't it? However, we heard that in the past 2 decades were also responsible for an unprecedented acceleration of technological advancements, and Klaus Meyer already highlighted digitalization was and is still high on the agenda, especially but not exclusively in air traffic control. And with adopting digitalization, we also opened the Pandora box of security and cybersecurity. As this would not be already enough challenge, so we also saw an acceleration of new entrants trying to get into our airspace. Uncrewed systems, they not only provide for economic development, but they also can pose security threats to us. And these are other security threats we need to manage. We started to rely on space-based services. Again, good, improved our work, made us do our job more efficiently, and helped us just in general. But coming back to the famous "I have a dream" speech, we here also have a dream about a safe, secure, and resilient aviation system. So allow me to introduce you to my fellow co-dreamers on the stage. Please join me on the stage. You want to stay? Okay. So we have from the European Aviation Safety Agency, Angeliki Karakolio. Angelique joined EASA in 2015 and works as a project certification manager dealing with worked as a project certification manager and deals with large airplanes in the certification directorate. She is mostly involved in cybersecurity related topics, and currently she is dealing with cyber threat intelligence and also is involved in Working Group 72, so aeronautical system security, and deeply involved also in the EASA GNSS activities task force. Next one, Okwari. He is a researcher at the Zurich University of Applied Sciences. He has a PhD in electrical engineering from Tufts University, is that correct? Tufts. Sponsored by the FAA's LAAS program office. And he has been working for over years, for 8 years in the DLR, so the German Aerospace Center, and where he led the effort developing resilient navigation services for civil aviation. He is also a member of Working Group 107, DME navigation for RNP. And he told me, although he's an engineer, of course he likes drinking coffee, but he's not afraid to talk to strangers. Michael Mabilier. He is an aviation engineer, specialized in GNSS in support of the Galileo and EGNOS program. Within the standardization team at EUSPA, so the European Union Agency for the Space Program. He graduated from the École Nationale de l'Aviation Civile in 2006 and worked in GNSS standardization for the past 17 years. He took over the position of Secretary of Working Group 72. Tim Dodge, the one with the furthest, travel today, he comes from the FAA. So he joined the FAA in 2022 and serves there as the division manager for the FAA Office of Unmanned Aircraft Systems and Emerging Entrants Security. That's a mouthful. The FAA leads organization for drone and advanced air mobility security. He is involved in US security-related rulemaking, research and development, and in his previous career, he was Deputy Director for the 371st Special Operations Command Training Squadron, where he was involved in training Special Forces operations. He has 20 years of active duty service in the US Department of Defense. Last but not least, Shimon Losa is a cybersecurity specialist within EUROCONTROL, specifically the EUROCONTROL Air Traffic Management Computer Emergency Response Team, the EATM CERT. He's an expert in cyber threat intelligence, has a broad range of skill sets, covering red team activities, blue team activities, and he is also experienced in establishing and operating security operation centers, one of them responsible for mission critical operations in an ANSP. He joined EUROCONTROL in 2016, and he offers experience regularly in forums like this and to the stakeholders of EUROCONTROL. With this, I would like to open the panel to a series of presentations, starting with Angelique. She will introduce you a bit on EASA's work on GNSS interference.
So, hello everybody. First of all, I would like to thank EUROCAE for giving us the opportunity to talk about the EASA activities in this wonderful audience. I will talk about cybersecurity. It's a hot topic, and I assume that's the reason it's after lunch. So, even though it has recently become a hot topic, EASA has already been dealing with this already 17 years, when a special condition was made available for products. Certification is one of the main activities of EASA. That's why focus was given there first with this special condition. However, in 2020, there was a change in paradigm, and from a resistance, we went to a full commitment approach by incorporating requirements in CSs and AMCs. However, EASA wanted also to have a more holistic approach to secure also the supply chain, and that's why Part IS was developed and published. This is a rule that addresses all organizations. And with this, rulemaking was complete. So currently, there is refining of AMCs and GMs through continuous development of standards, such as the ones from Working Group 72. Third pillar is information sharing. So we have two main streams. One is EXA, the European Center for Cybersecurity in Aviation. This is for industry members. And then we also have NOCA, the Network of Cyber Analysts. This includes member states. These are communities where, since a long time, trust has been built, and we can share knowledge, perform analysis, and collaborate. Last pillar is capacity building. Of course, technological advancements move rapidly, so we have to keep up. So training is one main element. And then the next one is research. I'll just give an example about that. I'll mention the IACT project. This is impact analysis, impact assessment of cybersecurity threats. It took place in 2017 and was concluded already in 2018. The objective was to assess the safety impact of a set of cyber attacks to communication and navigation systems. And recently we started an extended version of this assessment. A consortium has been chosen, and the activities are supposed are meant to start soon. And with this, I conclude very briefly the EASA approach to cyber. However, I've been asked to talk about a more prominent issue, and this is GNSS interference. For those who are not aware in the room, I will very, very briefly give the two definitions, because the colleagues that are standing next to me are going to delve into the detail. So, jamming. This is intentional radio frequency interference with GNSS signals. This prevents the systems to lock satellite signals. And this is okay, because at least the crew knows that they have a problem. And then we have spoofing. This is broadcasting counterfeit satellite signals to deceive the GNSS receivers. This causes them to compute inaccurate position, navigation, and timing data. And this is a bit problematic, because it can be the case that the crew does not realize that they do have a problem. What EASA does about this? So, we have identified two safety issues, and this is why I need my notes here. So one, it's over-resilience on satellite navigation, and the second one is GNSS signal manipulation leading to navigation or surveillance degradation. This is what I have here as SI0034 and SI5501A. This has been in the EASA risk portfolio for quite some time. However, it raised in the priority list after certain geopolitical developments. So the first safety information bulletin was published in February 2022 to address the topic, and this required this had recommendations addressed to NAAs, air operators, and ANSPs. Next step was a CAD-CAG. This is a collaborative commercial and transport collaborative analysis group. This group performs impact analysis. This is ongoing. February 2023, the Safety Information Bulletin was updated for the first time. And in September 2023, EASA created a dedicated P&T task force with members from all EASA directorates to be able to address the issue cross-domain. To avoid overlaps, this group cooperates very closely with the CNS program manager, and their goal is to ensure a minimum operational network. This is a very active group, and we can talk later about what they do. Then the agency decided to review the PBN implementation that happened October 2023, and its work ongoing. And the SIB was then revised once again. January 2024, there was a joint workshop between EASA and IATA. This was a very, very fruitful gathering. The task force intensified its work after that to implement the conclusions of this workshop. And at last, there was a CARI, certification airworthiness review item addressed to manufacturers. I think my colleague from Airbus already mentioned it. They need to check their own configurations and provide feedback to operators on how how to react, to inform and to react. And of course, parallel to all these milestones, we have occurrence monitoring. I'll go here really, really fast. So I just want to say that, look at the big graph. It shows you data from January 2019 to February 2024, and you can see the rise in occurrences. So this drives us to give our attention to this topic. And with this, I conclude my presentation, and I give the floor to my colleague.
Thank you, Angeliki. I think you can stay seated, so we just give it through.
Good afternoon. Does this work?
Yes.
And welcome to Switzerland. I'm Okwari. I work for Zurich University of Applied Sciences, and I want to talk a little bit about some of the stuff that I've done in the past on resilient CNS. I think of it as cybersecurity of a sort of different kind. When people ask me, how is this cybersecurity? It's cybersecurity in the sense that you have a cyber-physical system, because the airplane is a cyber-physical system, and if people are jamming and spoofing it, like Angeliki just said, you're messing with even the controls of it, and so it's something that needs to be taken care of, right? I need to be a little bit. I'm very thorough with citing all my sources here, because a lot of the stuff that I did with my previous employer, and they're very adamant about attribution. So you'll see everything has a citation in some form. We did a study there on looking at all the vulnerabilities in the different communication, navigation, surveillance systems, CNS systems. We saw that pretty much all CNS radio systems have some form of vulnerability or other, even if it's just that you could pretty much jam any radio system if you're really willing to put power out there. But just like you can jam GPS, and this is a picture from a flight that we did in the Eastern Mediterranean over Cyprus. This is Nicosia Flight Information Region. This was before any military activity started in Ukraine, so this is sort of prior to that peak in occurrences that you were showing. Back then, it was a thing to go measure what jamming actually looks like. We did it with the DLR airplane. We thought it was pretty interesting. There's a paper about it that's cited at the bottom of the slides. Something else that some of my comms colleagues looked at was you can actually create ghost airplanes in SSR. And if you're interested in seeing how that works out, you can read the other paper. It's an IEEE paper, so people can access it. And this is good that we have so many EASA people here. We think that regulators understand this, so aviation is actually safe, and that's an important message. At least as far as I can tell, aviation is safe. What happens is that you might be losing efficiency, and so communication, navigation, and surveillance are set up in a way, I think the FAA calls it the three-legged stool. You take one of the three legs away, and you can still operate on the other two, so meaning that if you were to lose navigation, for example, with communication and surveillance systems, you can still make your way back safely. It will not be as efficient, but it will be safe, and that's an important part of it. And another thing so I work a lot with performance-based navigation, and the colleagues in communication and surveillance talk also about performance-based communication and surveillance. The thing is that if you have performance-based navigation, a lot of things become more efficient because you can automate a lot of stuff, including monitoring for integrity, for safety, things like that. So you enable a higher degree of automation. The problem is that if you have degraded performance, you will lose efficiency. And that means a loss in capacity. And we all see the numbers. The air travel is bounced back after the pandemic and continues to grow. We're going to have to worry about efficiency again. And I'm not even talking about new entrants and UAM. That goes on top. And so what I think we need to be looking at more is multi-sensor navigation, multi-link communication, multi-layer surveillance, but also having multifunction radio links. In the morning session, I heard the word LDAX a lot, so I'm going to kind of assume that people know that LDAX is the best ever radio communication system for aviation. While at DLR, we also demonstrated that you can do ranging with LDAX, therefore you can do navigation, and it offers itself as a multifunction radio link like that, where we know that you can do communication. We've shown that you can do navigation. You can also do surveillance with it. So that kind of technology is something that people should be looking at more, in my opinion, because if you're fully trusting your GNSS solution and you're not cross-checking that against anything else, you are vulnerable to having this single source failure, and you need to be developing some sort of alternative for it. The discussion gets much more complicated if you start worrying about new entrants. I'm interested in that discussion. I don't have a lot of material on it. But what I really wanted to share with everybody is this new website that our lab just put out. I think one of the creators is sitting in the audience with a red sweater over there. No, you're not creator? Okay, sorry. Anyway, this came out of our lab. It's pretty recent. People are pretty familiar with websites like gpsjam.org that show where there's jamming in the world. The cool thing is this is actually spoofing. This is not jamming. These are occurrences of spoofing. And GPS, we don't compete with them, but we like to think that we've got a one-up because we can also provide you real time. They provide you, I think, a day late afterward. We can provide you 30 seconds latency on this because they're just measuring ADS-B messages. I think it's a neat website. Check it out. That's all from me. Thank you.
Thank you very much. Michael, your EUSPA position, what are you doing to make us more secure?
Okay, I'm set. Thank you for the floor. So, I have a few slides to introduce how we try to mitigate these threats from an EUSPA and EC perspective. This slide was to introduce the issue, but it has been fairly introduced by my colleague Angeliki already. It's other slides that shows exactly the same kind of trends. So you have the location, let's say. What is may be interesting is really to look from the report, the pilot report. You can see those bars on the top right that is definitely pointing to GNSS, GPS, as being the source of the issue. And we have the same trends from those information coming from my EUROCONTROL colleagues. We are definitely observing the same. So GNSS RFI is a growing threat. It's impacting navigation, but not only because of the way that technology starts to be integrated. So that's really something we need to care about and to find solution then to make it safe and secure again. And this is what we are doing, actually. We are acting to be more resilient. ICAO has developed multi-constellation and new augmentation standard. So you have on the left side a copy of the latest amendment of the ICAO Annex 10, including GPS L5 on top of GPS L1 standard, which make available GPS with dual frequency capability, plus Galileo dual frequency, Beidou dual frequency, and modernized signals from GLONASS side. So we have now a bunch of satellites that will be soon available to aviation with a commitment to provide performance toward aviation needs. So this is providing satellite redundancy, frequency diversity, and enhanced navigation capability, as you can see from the middle graph. I don't have the pointer, but those ones, this is coming from an EUSPA prototyping activity made by Collins Integrity, the Advanced RAM Augmentation Services. And as you can see, with 2 constellation dual frequency, we have 100% availability of RNP.1 over the globe. And losing 1 frequency, we still have 100% availability of RNP.3. So we have a huge enhance of navigation capability with some resiliency. And for precision approach with a dual frequency multi-constellation that you should picture as a second layer of SBAS precision approach capability, we will have almost global coverage of Cat1 with the evolution of SBAS and in introducing the new DFMC SBAS services into the current system. And at airborne level, we are also very active. The main groups working on that are EUROCAE Working Group 62 and RTCS Special Committee 159 Working Group 2. developing new standards for GNSS receiver that are more resilient toward jamming and spoofing. Here you have the ED259A that got published in September last year, which is already including requirements anti-jamming and anti-spoofing with testing procedures to assess the performance of the equipment. So it's not science fiction, it's not for tomorrow, it's already there. And we are validating right now this standard so it can be the baseline for future TSO published and ETSO published by FAA and EASA. And all this work is supported by the European GNSS program. EGNOS is evolving to provide enhanced L1S-bus services. As you can see, we will have extended coverage for the current services provided in Europe, thanks to the Galileo measurements. And Airbus Defence and Space is developing the EGNOS V3, the new evolution that will also augment Galileo. And with Galileo augmentation, as you can see, we will have Cat 1 capability in all Europe, including half of the Africa continent, as you can picture it in the slides. On top of that, Galileo is developing a new service that will be soon declared operational. We call it Open Service Navigation Message Authentication, and we have papers that will be coming to the next ICAO Navigation System Panel meeting to offer that service to aviation, so we can also at some point integrate those authentication tags to make sure you have the right information from Galileo side. And finally, with your taxpayer money, member states and the Galileo Reference Center is also daily monitoring GNSS performance so that we can further coordinate those observations with network manager and make sure that we can have the proper operational mitigation toward GNSS RFI occurrence. So that's it on my side, thank you. And here you have a link if you would like to be part of this work with us. We have an open tender right now that will investigate a solution toward resilience against RFI for airborne equipment, so feel free to apply, and it will be excellent to gather the best expertise in order to make progress on that. Thank you.
Thank you, Michael. So we were now above flight level 600, space-based services. Now we go a bit lower, unmanned systems, new entrants, and what are we facing with introducing unmanned or uncrewed systems into our airspace? Tim.
Good afternoon, everybody. Such a pleasure to be here today and share a little bit with you some of our efforts that we're using in the UAS and drone and advanced air mobility security concerns. As you know, the FAA, being a safety-minded organization, has to pay attention to security also to ensure that we have safe skies. In doing so, Congress asked us to look at a few things to ensure that some of the UAS and drone security initiatives ensured for safety moving forward. And that's a lot of the preface as we go forward and explain a little bit about this information is the items that we looked at are all around the auspice of understanding how these technologies affect the safety of our aviation space. Specifically, in 2018, Congress asked the FAA to look in 3 areas. And those 3 areas were conducting some testing, and the testing was in detection and mitigation technologies, and specifically what effects from a radio frequency, from a GPS, from spectrum analysis, what effects did these technology have in an airport and an off-airport environment against our airspace, ensuring we had safe airs. Second thing they asked us to do is, after testing, convene an aviation rulemaking committee. And that's a great opportunity that the FAA has to engage with industry partner members and actually ask industry, what are their thoughts, what are their concerns, and what are some things specific to these topics introducing detection and mitigation technologies into the airspace, ensuring safety. And lastly, the ask was us, once you have the testing data down and once you've gotten word and inputs from industry, come together with a plan. And how do we move forward? How do we integrate and look at our current policies, possibly new future policies, ensuring that as the need arises, as drones, as we're all seeing, are being more prevalent in the skies, how do we ensure safe skies and as much access to our airspace as we can for commercial, private use of drones? All while understanding that our security partners in the US have a need to make sure that it's secure. Happy to pass along that our testing, the first ask from Congress, we were able to complete in September of 2023, excuse me. We amassed 14,800 flights during that testing program. We tested these at 5 different airports, at different categories of airports in different regions across the US. We tested 22 detection systems in the airport environment, and then we also tested 9 mitigations. And when I refer to the mitigations for us, it's technologies that's looking to mitigate or take over those different drone systems. We also completed the Aviation Rulemaking Committee, we call it an ARC. We had 58 industry members. And those 58 members were a wide sampling of industry, from detection and mitigation technology manufacturers, airport communities, law enforcement and security partners. We had RTCA as a member, and ASTM, ensuring that we had, a full holistic approach from industry, making sure we were asking the right questions. And that question started with, how do we introduce these technologies from your perspective as industry? What challenges or desires do you have ensuring the safety of the national airspace? The last phase of that we've already started, which is the plan, incorporating all of those findings. The ARC produced a report with 60 findings to the FAA in January of this year, and we're fast looking at how to implement those smartly and looking at how to update recommendations for policies moving forward, and we hope to have an approach. We're going to be pens down at the end of this year, and looking forward to any advantages moving forward. As we look at security and the impacts of security, we look at it in a few ways. In the upper left, we look at crewed aviation, ensuring that any detection and mitigation technologies that are introduced by our security partners, what are the effects? We look at authorized UAS operations in the US. So commercial companies that are looking to do cargo deliveries and moving stuff forward. Safe, legal operations. We look at the air traffic control systems, making sure we don't affect any systems for our airport operations and communications and tracking with aircraft. And finally, we look at the effects of mitigation and detection technologies for people and infrastructures on the ground. So those were really the 4 core pillars or principles that we looked at, ensuring security effects would not negatively affect the safety of our NAS. So I appreciate it and look forward to any questions that you may have.
Thank you very much, Tim. And I think this is an excellent slide. It's very simple, but it's excellent. It explains really the dependencies inside the aviation ecosystem. And it also is a good transition. We were talking about space-based. We are now unmanned system, and now we're going back down to the ground systems, air traffic control. And specifically on cybersecurity for air traffic control, Shimon, what is your contribution?
Good afternoon, everyone. And thank you very much for the invite. Yeah. So let's talk a few moments about the cybersecurity in the non-CNS area fully. So who thinks that aviation is not a subject of a cyber attack? Can please raise a hand? No one? Okay, well, then I guess you will be bored here. So let's talk about 2022. 2022 was a very interesting year for us at EATM CERT because we have been able to acquire information about almost 3,000 incidents or occurrences related to cybersecurity incidents in aviation. So things are happening. We've got it through our own capabilities. We got it through aviation stakeholders who reported voluntarily that information and publicly reported events. Now, we had way much more information, obviously, but because the data we had didn't brought any analytical value, we decided to disregard it. But 2023, almost 5,000 occurrences. That's quite a number. That number doubled, but it's not necessarily because there are more cyber attacks against aviation. It might be because we are able to have more information thanks to the stakeholders who participate in the annual landscape report. We have more and better capacity to detect the information, and we were able to enrich information that ended up or will end up in our annual landscape report. So in terms of the annual threat landscape, you can see on the slide the overview of the things that have been happening all over the last years, how it was split across different aviation stakeholders. Now, interesting fact that the airports and OEMs seems to be targeted at equally same level, but the attackers are looking at the different things. The motivation behind those attacks, it's totally different. Those are not the exactly same cyber guys beyond that. And the CAAs, we are looking at the CAAs as well as a very important part of aviation industry and aviation community, but we have still quite a limited visibility in this particular area. We are working on it. But what is the most important here, that none of the cyber occurrences that we have identified, that we are aware, lead into a safety impact of the flight. So from that point of view, I concur with the previous statement that aviation is still safe. So who is behind it? Who do you think? We have quite a broad spectrum of the actors behind it. We have cyber criminal organizations. The best way to understand them, those are the thieves, those are the burglars that want to pay attention to mainly to the money. Then we have hacktivists. They have been quite active recently. A bit of ransomware operators and state-sponsored actors. Now, as you may see, also we have quite an unknown number, and that unknown number is just because we weren't able to attribute certain occurrences to a specific threat actor type. As I mentioned, financial gain, money, money, money. That's what drives the most of the activities concerning aviation. As you may can see, the estimated loss, it's 1 billion euros per year due to cyber attacks. So that's quite a huge number that we are trying to work hardly on lowering it, but still may be quite challenging to reduce only by factor of millions. Ransomware, a huge problem as well. As you may see, I have highlighted it. Ransomware happens against aviation. Ransomware will be happening against aviation, and the reason is unfortunately simple: we have money. Ransomware operators are not interested in those who don't have money, basically, as the main driver for them is the financial gain. And in average, we have been observing 1.8 ransomware incidents on a week. I am quite certain that in 2023, so in the report that we are currently preparing, that number will be a bit higher. By how much higher, hard to see, but already a year before, so in 2021, that number was a bit different. And as we are observing, all the cyber activities that are related to ransomware are going back on a track to the time before the February 2022. So that's it from my side.
Thank you very much. Some very interesting numbers you showed us, and also highlights that aviation is really, so we're not making up this kind of cyber threats to keep ourselves busy. There's really actually happening something. So I've received a few questions from the audience already. Would like to start with some questions I have to the panelists. Start with EASA, Angeliki. And a bit off the track of CNSS interference, because we know it's a hot topic and we're still trying to wrap our head around. More on a positive note, where as a regulator do you see that we're already on a good track when it comes to cybersecurity in aviation? So where in aviation do you see we're already on a good track when it comes to cybersecurity? I mean, talking about regulation, our AMC standardization. Where do you think that we are still lacking behind? Where do we need to do something? And I would like to combine it with one of the questions from the audience. Where do you see the NIS directive in this construct?
Okay, to answer your first question, so in terms of technological advancements, industries is moving forward. It never stays stable. It moves forward, and the EASA is already there to catch this. The domain that I would like to see some more effort, and this has to be from everybody, so regulators and industry, it's information sharing. So cyber, it's another animal, I would say. So we really need to create the infrastructure and the entities to be able to share between us. We need to build trust and certain frameworks to have a robust and resilient system in aviation. And what was your question from the audience?
So the audience question was focusing on NIS directive and the relationship
The NIS directive.
The NIS directive.
The NIS directive.
And how does it basically connect or link with what is already being done with Part AS and NIS? And yeah.
Okay,
why?
so there is EASA has a dedicated working group that explores the points that the NIS directive and Part AS touch each other. So we are also providing support to industry with pilot projects. We have pilot projects with operators and DOAs, and we also have dedicated meetings with member states who requested it to delve into Part AS, let's say. And one of the things is the NIS directive. So the interface between the NIS and the Part AS, it's one of the topics that the EASA is really putting some effort on.
Thank you. I can also add my 5 cents to it, having been involved in NIS development myself. We know there is still some room for improvement when it comes to Part AS and NIS, but I'm confident that the current efforts are ongoing and we're going to resolve the issue and establish some regulatory clarity. For Okuari, we heard, I saw on the slide of Tim actually, the topic about personal and ground security, or let's say, I was focusing more on the human side, on the personal side, seeing aviation always as a combination of system, procedures and equipment, personal procedures and equipment, and talking about skills. Do you have any suggestion how we could improve, how we train the next generation of professionals, being more aware, being better at having the right skills to face the challenges we are having in technology?
I have some ideas. And I do work for a university, so I think that's why you're asking me, right? I was actually, just before the panel, I was talking to Angeliki, and she was saying that EASA is looking to have some internship for people, and that we will, try to work with some of our students to send them to EASA. Maybe some of the other companies and organizations here are interested in hosting interns from our university. I'd be open to give you my contact information if that is the case. I think partnering between the universities and the organizations is really important. Not only on the teaching side, but also on the research side. I think it's important also to build relationships between institutions like EUSPA. In our case, it might be a bit difficult because we're a Swiss university, but we have very good relationship with FOCA, for example. I think it's important for the community to also take in research at very low TRL that isn't driven towards products, so as to keep an open mind in where things are going. Mm-hmm. Does that answer your question?
Yeah, partially. For me, it's more important. Do you think we need more push across the academia globally to enforce that we have here, especially in aviation, we have two disciplines, basically crashing, cybersecurity discipline and aerospace discipline, and there are very few academic programs where people can undergo basically being trained in that area. Do you think we need more, and do you have any idea how to establish such kind of motivation to do so?
You have a very specific view, and I like it. And my understanding, so I'm pretty new at Zurich Applied University. My understanding is that we're actually offering that. So people can't study computer science and they can't study aviation in parallel. I agree that it's probably somewhat disjoint. I think we're kind of doing that part right. I don't know how it is across other universities, okay, but I'm kind of agreeing with you.
It's good to hear. It's the first time I hear it, and I really appreciate it. I would like to see many more states having such kind of programs. Picking one question from the audience, it's on unmanned systems. Tim, I think it's for you. So for UAS mitigation, who is liable for such an operation? The business operator, airport, power plant, football stadium, or a state entity?
It's an excellent question, which was also a high point in one of those 60 recommendations we got out of the Aviation Rulemaking Committee, was a lot of concern around liability. Liability for detection, once the information is had by an organization, what is their responsibility to do with that information? And that's an answer that we just don't have yet. We're doing some real deep analysis right now of detection liability, and we're looking forward to the plan that we're creating right now through our analysis of the ARC report to come up with some good recommendations and how we look at that moving forward. It's a complex question, and from our ARC report, we found that several stadiums and organizations and institutions that have detection systems, some of those organizations own those detection systems, and some are looking at leasing and using third-party vendor systems, which further complicates the question of who owns the liability associated with that data. So as we move forward and as we find more information, we're happy to pass it along, but unfortunately this time we don't have a good answer to that yet, and we are looking forward to finding out.
Thank you. I hope this answers the question of the audience. Coming back to GNSS, Michael, you're most probably aware we have different GNSS constellations out there. With Galileo, we have GPS, we have GLONASS, and so on. Is there a difference between the susceptibility of interference of this GNSS constellation? Do you think one is more susceptible than another? And linking to that question, is there any possibility to check on the receiver side if something is spoofed or jammed? Do you have any ideas on this?
Yeah, thank you for the question. So the new signals, the ones that have been standardized recently, are stronger, more robust, because by design we try to make it stronger. You have to keep in mind that what we are using currently in aviation, when we say GPS, it's actually GPS L1C over A, which is a very old signal, initially designed to help acquisition of the P code for military use. So it was not really designed at the early stage to support all the things we are doing, actually, not only in aviation. So it has been a very good success. I think US and GPS could be very proud of the success story of GPS. But it's also fair to say that GPS program has modernized their signals. There is a new GPS L1C coming. They have done GPS L5 in a more robust way than GPS L1CA, knowing now how this system is being used. So I would say this one is a little bit weaker than the others. The others being stronger and less susceptible to jamming and spoofing. But that being said, this is the same technology, the same principle. We still have signals within the noise. That's the principle of GNSS positioning. So at some point, if you want to jam, you will jam. For that, none of those systems are fully robust against jamming. In particular, if you are hinting the central frequency. So that's one point. Then I forgot the second part of your question.
The second is more on the receiver side.
The receiver side. And actually, we are doing things. And I'm very happy to share that news because actually I've been working in Working Group 62 for quite a while. You mentioned 17 years. And we really did achieve something great in September last year. It's the first joint GNSS standard published with US, with RTCA. And actually this version, the revision A of ED259, is covering jamming detector. So we have already requirement to detect some non-nominal RF environments and in a standard way in order to output some information that could be further downlinked to ATC. So EUROCONTROL is working on a global concept of operation using that data from the GNSS sensor to be relayed by ADSB so that the ground is aware that one or several aircraft are being hit by non-nominal RF environments and therefore take decision, tactical decision, what they should do, keep going, contact those aircraft, well, whatever. This is still ongoing, but the point being, there is information going out that could be helpful on jamming. And on spoofing, this is actually the things we are working now for the evolution of that standard, the revision B of ED259 MOPS for the new GNSS equipment. The group has the will to have also a spoofing detector. So this is really new. It's coming from the last RTCA EUROCAE meeting in March. We set that bar, that objective, and we are working toward that objective. So in short, then, yes, there will be feature. There is a will in the industry and in institution to have capability to detect and to inform about what we are facing at aircraft level through those new equipment that will include multi-constellation, multi-frequency GNSS.
Okay, thank you. I saw you nodding, Kwari. Yes, go ahead.
Mikael, you brought up a really interesting point in the first thing you said. Would you agree that current spoofing attacks are still relatively simple compared to what could be achievable? I mean, currently, like, if you look at the website that I showed earlier, what's happening is that when airplanes enter that Eastern Mediterranean airspace, they all of a sudden start thinking that they're either in Beirut or they're in Cairo. That's a very simple attack compared to what could be happening. And maybe this goes to your previous question to me, Hannes. I think we need to try to bring the cybersecurity mindset to aviation in that so far a lot of security issues are cat and mouse game, right? You have the bad guys who come up with an attack, we need to fix it, find a patch. And the problem is that we can't necessarily issue a software patch that's available the next day. Yeah. I would say spoofing was invented roughly 2009, that was 15 years ago. And we've known that it's coming our way, and we don't yet have a solution. It's going to take another 10 years to make that patch and release it, right? I think that's something that we really need to think about some more.
Yeah. So to entertain the discussion on this, first things I would like to say is the GNSS sensor is a complex system, and the way it's integrated, it's also very complex. So actually, until very recently, we had serious doubts that main lines could be spoofed. It was not necessarily observed. But recently, we tend to see more and more events. So we think that even for that, there could be a threat vector that could be successful. There is ongoing R&D activity. If you are interested, I know that there will be results on that, assuming current TSO barrier, because we have a lot of monitoring for other reasons, for safety reasons in the receiver, that actually could be barrier against spoofing. So we are assessing our current level of mitigation without putting additional barrier against that. And results are expected in the next Working Group 262 meeting in June that will be hosted by EUROCONTROL. So join Working Group 62 if you want to be aware of what would be those outcomes. And all in all, yeah, what is also clear is that we know we won't, even if we have a spoofing detector, it will be under certain circumstances. Only some level of performance will be guaranteed. So what I try to say is that it will not be a complete solution, anti-spoofing, bulletproof, etc. The point is really to characterize what protection you will get and the level of performance you get from what would be designed by industry. At some point, we have also the idea of having claim tables, so they can also say, if they go beyond the minimum performance in the MOPS, to say then to an aircraft integrator what are their level of performance, so that at aircraft level, they can bridge the gap, provide additional feature, so that they are even more resilient against those things. So we know we are only part of the solution. Also what I briefed and what we are bringing from the signal in space is complementary to all actions that could be done at sensor and aircraft level, so that we have a more resilient operation, and we can still rely on GNSS at the end.
Thank you.
Is this,
I like it. But in the discussion before,
We're running a bit short of time, but please go ahead.
you had brought up that DLR antenna that can actually mitigate like all the jamming. You know, that's the kind of thing that I think, you know, if you're really looking forward, you need to be prepared for the next 10 years, right?
Yeah.
So you see, we have a fountain of wisdom here, so please engage all the speakers in the break afterwards. But I want to give the word also to, I have a question also for Simon. As I said in the beginning, that the fact that we are in a wave of digitalization, and of course we're not gonna step back anyway soon, because it just provides so much benefits to become more digital, more connected. But with this, we also increase naturally the threat landscape for cybersecurity, and being at the heart of air traffic control or ANSPs at Eurocontrol. From an EATM cert perspective, just give a bit of an insight. What are you doing to support the ANSPs, the air traffic control community, with your services? What kind of activities are you undertaking? How do you help them?
Well, thank you for the question. Well, you like to make our life hard, right? No, I would love to be able to answer it simply, but the answer is not simple. Meaning, indeed, I agree. It makes logically that the more digital aspects we are bringing to aviation, the more risks we are introducing. However, we need to take into account that we are able to perform and give a certain kind of countermeasures to those risks. And developing standards, developing frameworks, placing tools, modifying processes, it's one of the area that we should, or one of the few areas that we should focus. But I believe what we are missing, and we as a cyber community need to work a bit harder, especially in the aviation, we need to develop a security culture. It took years to develop a safety culture that we are safety oriented, and I see you're nodding because I fully agree what you stated, is that a cybersecurity culture mindset needs to be brought into the aviation. But I think it has to be done from both ways. First, the aviation has to understand the cyber aspects, but also the cyber experts needs to understand a bit of the aviation. Without those two working closely together, it will never happen. Because, yeah, question towards you, how many of you heard from their cyber aspects that you cannot do it? likely some of you. How many of you heard also that, okay, you cannot do it this way, let's do it a bit differently, but still let's make it possible? I don't see any nodding. So this is the mindset that I'm missing, that I'm advocating to force cyber people to understand the aviation, understand the business and the industry. Now to follow up, so at the ATM CERT we have developed a set of services that we are working together with aviation stakeholders to bring the cybersecurity component into their mindset, to develop a bit of awareness over the different scenarios. A simple one, phishing test, phishing awareness test. Phishing, one of the most simple techniques, still being actively used by all different actors that I mentioned. Hacktivists, state-sponsored cybercrime, that works. So that's one of the areas that we are working on. Another area that we are working on are the security assessments, the analysis of the architecture, or actually breaking into an entity, performing a legal cyber attack against entity. That's also what my colleagues are performing. And this is also a good kind of awareness, because we may think that we are very secure, but yet there are certain things that we have forgot about it, or maybe we were not aware. So understanding those things, performing this type of activities, and building the security culture, that's the area that we are aiming at, and that's something that I'm advocating for the aviation community to onboard as well.
Thank you. I could convince myself about what EUROCONTROL and EATM CERT is doing specifically. You do an excellent job, and if you're interested, look at the websites of EUROCONTROL. They really provide fantastic services if you're an ANSP, but also beyond. This brings us to an end, so I still would encourage you, because I still have some questions from the audience in my Slido, which we cannot deal with now. Please approach the panelists, ask them your questions. I'm sure they're more than happy to engage with you. Closing statement, I think you could see now that we have a multifaceted problem. We have an industry or an ecosystem that is slow in changing, because we have an emphasis on safety, and in safety we have the approach, if it works, don't change it. In security we have the exact opposite. If you want to keep it working, you have to change it. You have to patch systems, you have to constantly adapt your architectures, etc. So there's a conflict, so we need a bit of an approach to the different mindset when we're approaching or we want to be more future ready. I think in EUROCAE and RTCA, we, Working Group 72 specifically, we do an excellent work already with all the professionals involved. Also fostering the information sharing aspect, the aspect of shared risks, where standards specifically or explicitly mention that you have to do a risk assessment, but you cannot only consider your environment, but you also have to consider your interfacing organization, for example, also as it is highlighted in Part IS. However big the challenges are, and coming back to my introduction statement, I think we are, at least the people on the stage now, we are all strongly committed to live our dream and make aviation more safe, more resilient, and more secure. Thank you.
Well, thank you to the panelists for this great discussion. And continue with the agenda for the people that don't know me. I'm Javier Diana. I'm part of the EUROCAE Secretariat as Technical Program Manager for the Innovative Air Mobility and Compressed Aircraft System related activities. And we are going to continue with a flash talk on the topic of use of drone for lineage inspections. As you know, drones are being are starting to cover new areas of work that never have been imagined, focusing now in supporting dangerous and mechanical industrial activities that require a huge effort from humans until now, offering a great opportunity to do the same task with less risk, in less time, and with more efficiency. Linear inspections are part of this business, and I'm really glad to introduce the speaker for this flash talk, Gunter Graf. Gunter Graf is the Vice President of New Business Development from Frequentis. Gunter leads the Department for Corporate Research and New Business Development at Frequentis, and prior to this position, he was Director of ATM Automation, Head of Product Business Area, and Executive Assistant to the CEO, all at Frequentis. Gunter's missions in the company is to find and develop new ventures and technologies to foster growth within the current business segments of Frequentis. Core areas are the application of long-term evolution and 5G technologies in mission-critical communications and the safe integration of drone into daily life. Thank you, Gunter. The floor is yours.
Thank you very much, and thanks for having me here for now a bit maybe more lightweight topic. And because we were talking now a bit about security, about the data link, which is also for me a very heavy topic since years. We're trying to establish new data link technologies. And now getting a bit into the perspective of new entrants. We talked a bit about today how important it is to have drones and to look at these new entrants. And on the other hand, for them it's difficult. And for establishing new ways of aviation is not easy. Because sometimes it's really hard for new entrants to understand what is talked here and what is done here in order to enable stuff. Yeah? Sometimes when you stand not on the side of ATM and understand the complexity that we need to foster, that we need to manage, that we need to overcome, that we need to consider, when you're on the side of saying, okay, I want to just use drones for inspection, long-haul inspection, you think, okay, I'll just fly. The reality is it's not that easy. Yeah? Sometimes you feel more like Big Brother. It's, let's say, who controls the past controls the future. And when we look into what we are discussing here, it's not happening like that, and it takes its time. But I see also a lot of those steps that are taken when you look into the working group 105 for unmanned systems and what's happening here in EUROCAE. It really helps. It progresses, but still we have some way to go, and I want with you look a bit into that. I think one click more. Hope that video works. It was a click too much, I think. Yeah, it was a click too much. Need to be more patient. One back. Great.
Mud or rock slides, floods, storm damage. Climate change is increasingly affecting rail traffic. Sometimes there are just reports of overgrown vegetation or minor obstacles on the tracks that need to be checked. Previously, if railway employees wanted an overview of the situation, they had to go out onto the tracks. Even hard-to-access sections and their surroundings had to be walked and checked. Only then was it clear whether line closures and repairs were necessary and how costly they would be. All of this took time and extended the duration of line closures. State-of-the-art satellite-supported drone technology has changed the game. ÖBB is the first railway company in Europe to receive official approval to send drones along railway lines in a completely automated manner. This allows for flights without visual contact or proximity to the pilots. Working with Viennese technology company Frequentis, ÖBB Infrastructure is testing the real-life use of automated drones over an extended period. Drone hangars are spread along railway lines for this unique, highly innovative joint initiative. The drones can be launched and controlled from any working position by authorized personnel. High-resolution cameras send images in real time to the appropriate team members, who then immediately decide on the necessary measures. The drones independently recognize traffic obstacles on the flight route and avoid them. Redundant and self-monitoring systems, automated contingency and emergency procedures, and other security measures increase performance and operational readiness.
Die ÖBB-Infrastruktur sorgt für die Basis.
OBB infrastructure supports modern customer-orientated mobility across more than 5,000 kilometers of rail network and more than 1,000 train stations. We have started an innovative joint initiative with Frequentis, which will enable us to carry out automated and hangar-based drone flights.
Here at Frequentis, we primarily take care of the technological components within the project. The automations in the system ensure that operators cannot make any mistakes because all the standard conditions are stored within the system.
We can send the drone to the site within a very short time and quickly assess the situation. This allows us to provide the responsible personnel with relevant information and data in advance.
Durch den Einsatz von Drohnen.
By using drones, we gain valuable data. This allows us to further improve the lifecycle management of our systems. We become more effective and efficient, and that benefits our customers.
Innovative solutions for a safe and productive future for all of us.
I don't want to do some, I'm sorry. Here's the place for it. Don't want to do advertisement for that. I know there are other solutions around Europe that do similar things. But what is interesting, especially also for this round, we discussed long, and also I think Klaus, I don't know whether he's still here, from Switzerland marked, okay, we look at drones and we look at this stuff and want to learn from it and so on. What we see here, there is a bit of a shaking in the system. Aviation is used to have airlines, airports, ANSP. This triangle somehow organizes the whole stuff. And there are very important stakeholder things that do, people that do stuff like pilots. When you look into that here, and I know the drone is small, but it could be bigger. It is that small because of all the rules we have to follow. We would like to have it bigger, but if I make it bigger, I will not fly autonomously. So the issue is I want to take out the pilot of the equation here in order to help grow, in order to help make the automation, and to help and to use new technologies and extend the aviation frame. And I think this is exactly what, let's say, shakes a bit the system. What we also saw today in the morning with new data link that changes the system a lot. And when you have a complex system like worldwide aviation, changing that is really a complicated, complex task and takes forever because so many stakeholders and so many, let's say, called automatic stabilizers sneak in. And we have the same here. In drones and UTM or new entrants, be it eVTOLs and so on, parameters of the overall systems need to be changed or even integrated into the system, like what now happens with the new standard for geozones. It wasn't even possible to integrate new entrants because we didn't have rules for unregulated airspace. This happens now. And now we have the problem that these applications somehow fall into an area where still no regulation is there just because the problem hasn't existed. So all these things we are driving, and I think this is the way we can move it forward. Because when we look into the past of the aviation system, it did not change because somebody planned it. Sometimes when you look into drones, we just transfer thinking out of the ATM world and try to modify it a bit and apply it to what we think drones would need. I think what we need to do more, and this is what we try to do here, is look into concrete use cases, what needs to be done, where is the real benefit, where can it happen. These are things that can happen. There are many, many countries, many, many applications where all those linear inspections, for example, need to happen and bring benefit. And the rules need to be made for this. And I add on a bit to that. At the end, we always have the same setup. We have a control center, we have some sort of ATM, we have the network, we have the field. and we have what we call now a hangar. At the end, we post a flying object somewhere without having all the procedures around and the pilot. And that's quite complicated. For us in Frequentis, you might ask, why are we looking into that? That's our business. Just skipping that I don't keep you too long from your coffee. But there are many potentials where that can be used too. So this is what I said, inspection. This is really bringing a lot of benefits. But in order to do that, a lot is needed. I will show that afterwards. It is also very much used and very much thought of in public safety, but still not very widespread use, just because use space isn't there, a lot of rules aren't there. In many countries, they would be able to send drones around, and it is measured and clear that it is a big benefit, but at the end, rules are missing, stakeholders are missing, observation is missing. It is not clear who is responsible. In many countries, still it's unclear who is responsible for that stuff because the ANSP isn't and the legislation isn't clear. The same is for border protection. Sorry, I think I mixed it up because I'm not allowed to. I need to look here. There's border protection is one thing, and the other thing is public safety. Sending out drones in order to clarify an occasion. You are much faster with a drone than with a car. You can't send helicopters or whatever in cities all the time to clarify an accident, but with a drone you are faster. There are a lot of measurements how well that would work. However, coming down and thinking, what could we do? What is the next step? What is the logical next step that really could trigger the next step? Because this is the only thing you can do in complex system. Is at the end, look into the overall technology. There are a lot of parts that we have in there. There we have this hangar that you see in the video. You need to have the control system. You need to have the network reliability and hardening. You need to have all those things. But at the end, what we want to have and what we think would enlarge the aviation would bring additional benefits and would integrate drones much more with real BVLOS, so beyond visual line of sight use case, is having infrastructures, drones out there that we can address autonomously, have hundreds of such objects in the field, and that could be used for public services, for police, for inspections, for real benefits of the society. And in order to do that, we think the most important thing is that we look into this hangar and to say, okay, how can we address that? Because currently there are, we found around 100 startups around the world, and we found a lot of companies who are doing that stuff in different ways. But we have standards for the traffic management. But I don't have a standard or whatever for accessing those automated stuff. I cannot define currently how it looks like if I want to start automatically somewhere in the field the drone. This all needs to be built individually. And so, closing remark from my side, this needs to be done. This is something for Working Group 105 to say, hey, there are those flying objects, different ones without pilots, small for the time being, but acceptable maybe for the whole framework. Let's do something for that. We will do that in Working Group 105. Look into this, make one step after the other, try to integrate those drones that fly autonomously, currently small, maybe in future larger. Because this big step to have large flying drones, maybe even with persons on board, will not happen if we don't manage even to have a data link. So, closing remarks, it's really about dreams. How can we improve aviation? How can we get to these visions of Cannes and so on, 2045? You know all these fancy pictures of drones and helicopters and all of that together over one airspace. If we really want to reach there, we need to do small, maybe baby steps in order to get there. But we need to do them, not just talk about it, need to be implemented. Only then it gets forward. Thank you.
Thank you very much, Günther, for this very interesting real-life example of the use of drones for linear inspections. I would like to now invite everyone to go to the coffee break. We have, again, a coffee break upstairs until 15:55. We're starting a little bit later on the coffee break, but I think we still want to give everyone the time to enjoy that. So enjoy your coffee, and welcome back here in 45 minutes.